All right, so yesterday we were working on a cardboard box, right? And we came up with the formula for the volume of the box.
X equals 15 minus 2x.
15 minus 2x.
And 8 minus 2x.
8 minus 2x.
Plus I didn't get the rest.
Times x, right?
Yep.
Okay. And then what we want to do first is find the domain of this function. Okay. Now, normally, based on the lies that I have told you so far this year, you would look at that and you would say, we're not ever dividing, so I don't have to worry about dividing by 0. We're not ever taking a square root, so I don't have to worry about taking the square root of a negative number. Therefore, the domain would be
7. Infinity, negative infinity.
right, negative infinity to infinity. Okay. However,
Lies.
we are talking about a physical, real-world problem here, where we're cutting corners out of the box. So say that again. So cannot have negative. So what is the smallest value of x that we could cut out?
1.
Right, 0.0, something just above 0. So I'm going to use a round bracket 0. And then looking at this stuff up here, what is the biggest value that x could be and still get a positive answer? Rebecca?
Is it 8?
It is not 8 because if I plug 8 into here, 2 times 8 is 16, and 15 minus 16 is negative 1, so 8 is too big.
7.
7, okay, 2 times 7 is 14, da, 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 so that works, but what about this guy over here? No, too big. Okay, 4, if I cut out 4, then this would be 0, right? So the smallest would be 0 and the biggest would be 4, okay? And it can't be 0, because then we wouldn't have a box, bless you, anchors are tight. And it can't be 4, because then we wouldn't have a box. And so that's why we're using round brackets on most of those. Does that make sense?
Someone could do the 4th if you could.
Yeah, if I tried to cut out a cardboard square bigger than 4 inches, if this side of the cardboard is 8 inches, what am I going to be able to do? Okay, good. All right, so now let's find the size of the square that I should cut out to give me the maximum volume.
Should we play along or watch you do it?
That's up to you, doesn't matter. So I'm going to type this equation into my calculator. What did you call me? And if I graph this, then I'm going to have some issues. Because I really can't see what in the world is going on.
Why did they put me back to that one graph?
You have to clear it out. You have to clear it out.
I did clear it out, though.
I don't know. And so I'm going to change my window. Okay, all right, so a couple things. First of all, like Evan said, you have to clear out any functions that you had graphed previously. And then you also should go up here and turn off this stat plot, so those little dots don't show up anymore. Okay. Okay, we're not zooming anything right now. This is zoom. Okay, we'll talk about that in a second. So right now we can't really see what's going on. Okay, so that's where the domain is going to come into play. What was the smallest x value that we said we could use? 0. So I'm going to use 0 as my x minimum. What was the biggest x value that I could use? 4. So I'm going to use that as my minimum. What is the thing about the range now? What is the smallest volume that we could come up with for this box? Can we have a negative volume?
No.
No. So I'm going to go with 0. And then for this, we just have to guess. What do you think the biggest volume will be?
25.
25. Okay, so let's take a look at that graph. And Forrest is not quite correct because the graph goes up above
38.
25.
What's
Okay.
the, wait, what's the y? What's the y, 25?
Yeah, we picked 25, but that was wrong. He says 38. So let's try 38. And it turns out that 100 is a pretty good guess. Nice job, Forrest. Okay, so if I make this go from 0 to 4, because that's what our domain values were, and if I make this go from 0 because the minimum, volume we could get would be 0, and then kind of guess at a maximum of 100, now you can see the entire graph, okay? Yeah.
Okay.
Okay, good job. How do I find now the maximum volume that I want?
The peak.
I'm going to go to maximum, so I'm going to go second calc, which is above the trace button. Option number 4
Left bound.
is maximum.
We just do the left bound thing.
Left bound, so you can either name a number to the left of this top peak and then hit enter, or you can just use your cursor to scroll to the left of that and then hit enter. Then to do a right bound, I do the same thing but opposite. And then for my guess, I'm just going to move it right up to the top there and hit enter. And down here, it will tell me that the size of the square that I should cut out of that cardboard to make the maximum volume is what? That's the maximum volume that I would get. 1.6 basically repeating, which is
1 2/3.
1 2/3. So if I cut out a 1 2/3 inch square from each side of this box, then I will get a maximum volume of about 91 cubic inches. Okay? How's that sound?
Pretty decent, I guess.
Pretty decent?
Sure.
All right, so that is all I'm going to do with you today, since we did most of this yesterday. So I'm going to give you an assignment right now. You'll have lots of time to work on it. So hopefully if you apply yourselves, you won't have homework this weekend.
I'll go to the library, I don't care.